This is 0. Oops. This is 0. This is pi by 2. This is pi. This is 3 pi by 2. Okay, so the question was, how did we get that cos of pi by 2 is equal to 0? Okay, from the task rule, the way it's going to go is that we said that theta cos is the x value, so 90 degrees your x is 0. That's where it actually comes from. That's the graph of sine and cos. Actually, will come in the graphs in a little bit. So yeah, if something is in the first quadrant, everything's going to be positive. If it's in the second quadrant, sine is positive, everything else is negative. Third quadrant, tan is positive, everything else is negative. Fourth quadrant, cos is positive. This is coming back from last semester, I hope. Yes. Or 2 years ago. Yeah. This extra 0 degrees, sir. Right? Because remember the way theta works. It's going to rotate like this, right? That's how angles are measured, right? So start there and go in that angle. Now we all right? Here. Special triangles. Okay, so what I'm going to do is I'm just going to do things you should know coming into this course. I'm going to assume.
May your attention, please, with all students with the last names beginning A through L. Please report to the cafeteria to see them on the house nurses for your inoculation. All students with the name, last name A through L to the cafeteria for your inoculation. Thank you.
Okay, so what I plan for the rest of this trig part, I want to do the special triangles. I want to prove the special triangles. Then I want to solve an equation like that. Okay, and then I want to do a graph. Okay, using the way you do it in advanced functions. Okay, the way we're doing calculus is we're not just graphing sine and cos. We're graphing like sine bracket x squared, right? Or sine of 3. Yeah, or x squared sine x. And the back special triangles. So start with be pi by 3, pi by 6. All right. Pi by 2 triangle. Okay, how do you get the 30, 60, 90? That's what it's supposed to say is 30, 60, 90. How do we do the 30, 60, 90 triangle? You have to memorize already, but you do draw a triangle and chop it in half in grade 11. What triangle do we draw in half? Yes. An equilateral triangle. Okay. Yeah, but if you don't need this proof, I will not ask you to prove this. But why do I use an equilateral triangle? All sides are the same. This is also going to be 60, 60, 60, right? So that's an equilateral triangle has. Okay? What I'm going to do is I'm going to chop it in half. Okay? That's going to turn this into that's still pi by 3. What is the top angle going to be right now? I know that's it, so half of that, right? And that's 90. Are we okay on where that's come from so far? Oh. Good stuff. Oh, yes. Degrees are gone. Degrees are gone in calculus. But okay, that's how I know why degrees are gone. Because you can't. Radians are not numbers, right? So if I take the derivative and there's something with a number, that'll work with it, right? If I were to take the derivative, let's look at the degree. What's 3 degrees times 4? I don't know. But what's like a third of a radian times 4 less 4 3 radians, right? So the real numbers can work with radians and degrees. Okay, well, how are you going to sidelines after all that? Yeah, so what I'm going to do is I'm going to start off with every side starts as 2. Why might it make sense on my original triangle that every side was 2? Right on. So I'm going to say 2 squared equals 1 squared plus x squared. 4 equals 1 plus x squared. X equals root 3. And there's your triangle. that you should be able to use very easily. Okay, so if you get an answer that says root 3 over 2, you should be able to give me an exact answer. Okay, if I were to say sine of pi by 3, please do not give me 0.866. Okay, because I will be upset. Okay, so if there's anything that works out nicely, multiples of 30, 15, like a 30, 45, 60, if those work out nicely, please give me the exact answer. Oh, you guys don't get excited about trig. You know the worst thing I got calculus? I didn't do this review. I just expected you guys to do it. And I went and I did my first lesson, and she was just like this. Right? So I'm not even kidding. So I complained to the advanced functions teacher. He said, well, I taught it, so. Alright, let's do the other triangle. How do you get 35, 45, 90 triangles? Yes. No, I gotta do a little more things first. Yeah, we're going to have half a period test for you. We're all going to study. Okay, how do you get 35, 45, 90? What is that? Square. I chop this in two. I'm going to end up with, there's a 90, there's a pi by 4, 1, 1, root 2. There's a triangle right there. Okay? I come back? I hope? You should really know it's true. Yes. What else do I want to talk about? Let's do a little bit of a few more things you need to know. A few other things to know. I'll look quick. I'll pick it up for if you want to study here. I'm going to say that sine pi minus theta is equal to sine theta. Cos of 2 pi minus theta equals cos of theta. What is 90 is 5. Okay, these are 3 other things that will be useful to you. Right there on top of those right now. Those are 3 things that are useful to you right there. Yes. Yes. Well, I want to ask you to prove this. It's expected that you guys to prove this in grade 11, I think. I know I made you guys prove this in grade 11. I would say if you go back, you had to do that many moons ago. So no, you will not get it down. Hypothetically, you could use 100 and 100. Okay. So all that would happen is this would be 100 times root 2, so you could bring everything down to the lowest term. And the same thing with this one. You could have used 1, 1, and 1, but the problem is this would have been 1 over 2, 1, and then I would have 3 over 2. Okay, other 3 things, good things to know. I want to do now with the question there, stop here, then I'll stop here, okay? This is going to be on warm up. And then I'll move on to lesson 6. So I want you to solve 0 plus equal to theta. Let's just say 0, not 0 degrees on 40. Bad habit I've taught for 11 years. Let's move to 2 pi. Where 4 is equal to 2 sine 2 theta plus 3 without a calculator. Okay, this is a really cool question. I love this. And I sat in Mr. Lacey's class all of last semester, so I know you guys did this, even though you're going to tell me right now you've never seen this before in your life. Secondly, I taught 3/4 of grade 11, so I know you did this in my class in grade 11. Okay, so the questions were messier than this, because I don't give nice answers. Okay, how do I solve the data? What's the first thing I need to do? Yeah, good. You certainly could. So this is going to be 1 equals 2 sine 2 theta. Let's come back, yes? Next step is what? Keep going.
You can do 1 equals 2 sine theta plus
Yes. I'm going to make sure this first. I'm just going to go like this, okay? For the next. If sine of something is 1/2, what is that something? 5 by 6. So sine, yeah, this is 5 by 6 equals 2 theta. How do you know that? It's that triangle, you know it's that triangle. Okay, so if you do sine of, okay, if I do such a triangle, I'll go back here. If I want 1/2, it's going to be opposite of the hypotenuse, right? So the opposite to 5 by 6 is 1, the hypotenuse is 2. You guys were tortured with last year. How many of you guys were tortured with for Mr. Kemp? Yes. I'm going to call you over right now. Just stay with this. Call him over.
Let's not waste time.
Okay. So yeah, so you guys were tortured with last year. Somebody told me you guys do this before? We did a lot of you guys did this, right? You did this in the webinar, you done?
Oh, you put the one down on the hypotenuse and you pretend it's the hypotenuse.
Okay. Oh, I thought that was Mr. Kemp I was wishing. Hi, how are you?
Hi. Okay. Which one factors?
One.
Yeah. How's it going? Somebody else good? Yeah, talk later. We'll stop talking.
Okay, thank you. Thank you. All right. So theta is pi by 12. Okay. All right. This might be very new to do with natural graphics.
Yeah. I still
Okay. We can grab this tomorrow. Okay, this way here. So it's going to be the way you do this, guys, right? So base your area, so sine inverse. 1/2 is 2 theta, right? So what's going to happen is for sine, guys, tell me please. Sine is equal to opposite of right values, right? Right? So sine of theta, in this case, is going to be 1/2. Right? So sine of 2 theta is opposite of 5.
Oh, I see it now.
Yeah.
Numbers are like forward.
Yes. If I say to use a calculator, I will. Okay, I can expect some of this. Okay, now we're not even close to being done. We're not even close. Let's use cast rule, okay? What cast rule outside that is five? Yes. Yes. Okay. So we're going to say pi over 6 is 2 theta, or pi minus pi over 6 is equal to 2 theta. And this is Castro. Okay. If you don't like Castro, you can just say that right here. You just want the line right instead of Castro, right? Because you do it as soon as you get rid of your sign right here. So this is the point that's the stuff that we use right here. No, not at all. No.
Then why did we do that?
Sorry?
Why did we find that? What's the point of finding that?
Because you need that at 35 minutes. We're not done yet. We're not even close to being done. No more. Yes.
You had an answer, it was like when you got rid of the sign, it was greater than 5.
Yeah.
Or
Yeah.
5.
Yeah.
Would you do 2 pi minus 4 and 3?
Yeah. You got it. Yeah. Yeah. Yes, sir.
You have to give them all.
Okay, now we're not done yet, though. We're getting close. We're not done. You guys did this in last semester. Please tell me you guys did this last semester. This is some of you do. We're only half done. The other 2 answers. How do you get the next 2 answers? That's fine. Now we're going to add my period, which is 2 pi divided by k, which is 2 pi divided by 2, which equals pi. So this is going to be theta plus 13 pi over 12. Theta equals 17 pi over 12.
And you have the period.
Yeah, 2 pi over k. So it's 2 pi over k. K is going to, can we do a graph? Let's do a graph.
We can graph that. Let's say K in the equation.
K in the equation is here. The equation number is this one, y equals a sine k theta minus b plus d, something like that.
So we need 2 there.
Somebody to see, yeah. That's like your horizontal compression. this graph repeats every pi, right? This graph repeats every pi. Here we're sine's a curve, right? So this graph's going to repeat every pi. So I've got my first answer pi divided by 12. So it's going to repeat again and get to 13 pi over 12.
Does it change for the, like, this host?
No, it's all just over. Good question. Okay, because 2 pi is a regular period, but our graph has been stretched by a factor 2 here, compressed by a factor 2.
Oh, it is.
It is.
Wait, what?
2 pi divided by k, 2 pi divided by 2. That's it.
That's the first time I've heard.
If you have questions about what I just did, yeah, come see me sometime. Okay, this is my overview for the problem. So my back test would be ready.
How many know look like parameters, like, yeah, this is pi?
Yeah.
Is that why you're on using pi?
Yeah.
I'm gonna, so if you have this pi, you have 5 or
Yes. What I'm going to do is I'm going to graph this as my warm-up on Thursday. Right, my Thursday warm-up is going to be on my graph, sine graph, and the close graph, just to remind you guys what those are. Let's go to the test right now, though.
Yeah.
Okay, task for the other go through. Did, Austin, did you hear my video? Austin, I think that video even had like jokes in there. I said, Austin. No, Austin.